timing. Let's see, does it work? I hope it works. Oh 妈呀，又开始来了吗？不对。OK， At first, the array is sorted, so it's 0, 1, 2, 4, 5, 6, 7. And then, after it's rotated at some pivot unknown, it becomes 4, 5, 6, 7, 0, 1, 2. And if we want to find the minimum element, and we cannot do sorting. Now, we cannot do just simply sorting, no sorting algorithm, you have to use something else. To find the minimum element, then we know in the binary search, we segment the array to two halves and then target the number we want on which half, and then we continue segment the half to halves. Here the same. Let's try binary search this algorithm, because of course this question is in this in the binary search section. Left is pointing to 4 and right is pointing to 2. Their mid one, the mid index is 0, 1, 2, 3, 3, because 4 is at index 1 and 2 is at index 6. Okay, is that right? 1, 2, yeah, I'm saying okay, yes. So mid array of mid is 7, and we compare 7. The second step in my solution is to no, not in my solution yet, but my first try is to compare 7 with array of index of left and array of index right. Array of left is 4, array of right is 2. Then both of them are smaller than 7, but then we have to check because now we have to decide this is the start of a segment or the end of a segment. How to decide? I don't know what I'm saying. Oh my god. 頭埋我隻手啊，點解？呀，咁邋遢。For example, we compare 7 with 4. The difference is 3. Compare 7 with and 2, the difference is 5. Because oh no, actually we don't need to do that, because mid must be behind 4 and in the front of 2, which means there must be a number smaller than 7, which is there is a number that is smaller than 7 and the index is greater than 7, because 2's index is greater than 7. Then we know, okay, we can, because we want to find the minimum. When we want to find the minimum must be between 7 and 2 among this range. Then we move the left pointer to mid. Actually, mid plus 1 is okay, because 7 is greater than 2. We have known this, but just to be secure, make left to be mid. And then right doesn't change. Right still points to 2, which is index 6, and left is now index 3. And we find a new mid again. 3 plus 6 divided by 2, which is 4. because each divide by 2 should be 4.5, but in Java it's 4. So the 4 mid is 4, which is 0. And we check 0 is less than 7, but greater than is less than 7 and 2, and this mid is in the front of 2. So we know that it should be between 7 and 0. At this point, we have to check the while condition should be left is less than right. While left is less than right, 7 and 0, between 7 and 0. Then 7 plus 0 divide by, do we need to divide? Let me see how to exit this while loop.哎呀，已经这个点数嘞。7 plus 0. Do we need to check? We have to move the right. Right is now equals 6 pointing to 2, but move to index 4 pointing to 0. So it becomes 4, 5, 6. 4 to 6 we are ignored, and then 7, 0, 1, 2 left, and we move the mid. Move the right pointer to mid. Do we need to check again? We have to check if left is less than r minus 1. Yes, if left is less than r minus 1, then we can find a mid between them. However, if no matter what else, we don't need to find a mid, and we just come out and check whether left is less than which one is smaller than that one is the smallest. However, for if I like this 2, 1, mid is this, while left is less than. Okay. So the abnormal case is if the array given is null or the length is less than 2. Less than 2. It's less than 2, then it will be 0 or 1, right? If it's less than and is equal 0, then it must be you just return nothing. Yes, return 0 maybe, or return no. Let's see, find the minimum element. What about find minimum and rotate it? Okay, the constraints is the length must be less than or greater than or equal to 1 or less than and or equal to 5,000. Okay, then it's fine. And all the integers of nums are unique. These constraints, if in an interview, you should ask the interviewer. Okay, and all the integers of nums are yes. Then you just need to check if nums dot length is equals to 1. Then just return nums 0, right? If there are 2, and then you can go to while left is less than right minus 1. Do something, the process I just said. And while left is not less than right minus 1 means while left is less than right. They are adjacent. When they're adjacent or points to the same one, it cannot be point to the same one. If while point to the same one, that's the first situation about the num star length equals 1. So when they comes out, they must be next adjacent to each other, and we just need to check if ARR left is less than ARR right. Then what? Return ARR left. Else less than, oh, they are unique, so they won't be equal to. Else return ARR right. Okay, then we use another example to check. For example, 2, 4, 5, 8, 9. And now, oh no, just use 4 elements. 0, 1, 2, 3, 2, 4, 5, 8. Okay, and left is 0. Right is 4 minus 1, 3. And the mid is 1 because 3 divided by 2 is 1.5, but in Java it equals 1. So the mid is 1, then points to 4. 2, 4, 5, 8. Left, mid. Oh, but you have to, oh wait a minute, rotate in some, rotate. Okay, forget that. You have to rotate. Then it will be 5, 8, 2, 4. So left is point to 5, right is point to 4, and mid is point to 8. The mid is greater than left, so, and 8 is greater than 5, then it's fine. It's fine. Okay. And mid is greater than 4, but mid is in front of is, but mid, this index is less than right, which means the minimum element should be in the range from 8 to 4, means from index 1 to 3. Then move the left pointer to mid, which is 1. Okay, so now left before is 0, now left is 1, but right is still 3. And 1 plus 3 is 4. The mid is 2. So mid is 2 and it points to 2. 5, the left half of, or the left side of the original mid can be ignored. Left, right, and this is mid. And mid. Okay, mid is now is still greater, the index mid is also an index, is greater than left, but mid is less than 8. ARR of mid is less than 8, and mid is less than right, and the value of mid 2 is also less than right, less than the element at right pointer, which is 4. So the pivot, or the smallest one, should be between 8 and 2. Then move the right pointer to 2. Now right is 2, L is still 1. And while left is less than right minus 1, no, they don't qualify this condition, so they just finish and this while loop and the while loop and come out. Compare the element at right pointer and the element at the left pointer. Coffee is good. Let's try first do this one and try something else maybe. If it's not right, it doesn't matter. We can try something else. Okay. For example, 4, 5, 6. 4, 5, 6, 0, 1, 2. 0, 1, 2, 3, 4, 5. L is 0, R is 5. And the mid is 2, which is 6. Wait a minute. Oh, doing this. Oh no, wait a minute. 7? Like this. Okay. Rotate. But if rotate. Okay, if in this way, then 6 mid is greater than 4. So all these numbers and this. This one, the index mid is less than R, but the value is greater than the element at R, at right pointer. So the minimum one, we still have to check which difference, right? We still have to check. Ooh. Back O of N. Wow. This is good. 暴力解法 brute force. Traverse. Oh yes, big O of N. You just need to traverse the whole array and find the minimum, the minimum element. It takes big O of N time. And you can also we can use the characteristic of rotated array. If nums left is less than nums right, 我直接 return nums left. Yes. Oh, 你唔記得咗呢個 If after rotate, the element at the left is still less than the element at the right, then, for example, if you also check the mid one is greater than 1 but is less than 5, this is an assorted array. We just return nums of left. Else, what a good handwriting. Good. Yeah, man, so cool. And then the next is, if nums left is greater than nums mid. If nums left is greater than nums mid, say 1 5 4 1 2 3 0 1 2 3 4 is mid to right 右最 left 同 mid 之間0 right 等於 mid nums left 係小於 mid。 說明 nums left mid 有最小值係喺 mid right 間之間0 left 等於 mid plus 1。 We still need to check this. I don't think about this. discussion based on different cases. Compare nums of left and nums of right. If nums of left is less than nums of right, means the array is not rotated. It's still in ascending order. We can just return. Wait a minute. 有冇講話係 in ascending order? Oh, okay. Sorted in ascending order. Return nums left. So 就非單調。但是你怎麼知道呢？ Rotate. After rotate, the last element must be smaller than the first element. OK， 定律嚟嘅。第二次分類 ，nums left 同埋 mid， 其中 mid 係 left 係大於 mid， 右半邊係升序，就不用考慮右半邊了。係 left 同 mid 間 left。譬如嗱，你講一個4、5、6、7、1、2，係咁樣啊？都係大個咩？0、1、2、3，譬如咁樣，0、1、2、3、4，0、1、2、3、4，佢係細嗰個。等一下，等下係咁嘅意思。如果mid 係少過 right， 係如果 mid 係少過 right， 肯定係同呢度到呢一句。如果佢係少於等於係大過 right 嘅話，開空間，我哋 do it by ourselves one's time。我哋冇做嘅係，我哋冇做嘅係呢一個步驟，我哋覺得唔需要 ，we can do it by， 我哋冇同一個都一定要做。No， 呢個意思case。Though it says the array is rotated, we don't know after if the array is still the same after rotation, and a sorted array in S is rotated if oh no, wait a minute. Length must be 1 to 5,000. We can forget this abnormal case. We can just check if num stop. Is rotated. 小听吗 We use left less than right when they are equal. Left. Okay. Try here. And submit and try whether it's accepted. Oh yes, okay, that means y is okay. We can leave the while loop while they are adjacent. They don't need to be, the left and right are not the left and right can be equal or not when we exit the while loop. Okay. This is done. The next question is maximum number. Maximum number. Peak element. Let's see. Is that the same? I'm not good. Yeah. Common shift. Oh, wait a minute. Common shift. Solution. Given a mountain sequence of n integers which increase firstly and then decrease, find the mountain top like this. Find peak element. A peak element is an element that is greater than its neighbors, given an input. Find, return what you should return. Given an input array nums where nums I is not equals to nums I plus 1, find a peak element and return its index. Return its index, okay? It's different from returning the exact value. The array may contain multiple peaks. Oh, it's different. The array may contain multiple peaks. In that case, return the index to any one of the peaks is fine. You may imagine that nums -1 equals nums n equals -infinity. 잠깐만. writing down. Oh, continue. Oh, which is different. In this mountain sequence, there is just one peak element, but find peak element. There may be several peak elements. Okay, this is the difference. To be honest, this maximum number in mountain sequence is similar to the previous one minimum number. Wait a minute. Search. Oh, shoot lah. 操，等等 minimum. This is optional. I switched the tab. It's optional. Well, it's also, I think, similar to require. And this is the next one. Maybe we make it is find peak element is the next one. Okay. Maximum number in mountain sequence. Again, we just use the binary search. For example, this one, the left points to 1 and the right points to 3, and find the mid. If the mid is greater than 1, and if the mid one is greater than the left one, then the mountain top must between the mid and the left. If, for example, we do in this way 129A63 129A63 0 and it's this part part, it will be here, and if it's 10, 9, 8, 7 left and right. If it's less than 10, then less than the mid one, less than the left one, it must be the left side from left to mid. I think it's similar to the question about find minimum and rotate sorted array. Try once. Oh, that's what it's weird. On paper, not on the paper. Oh, that. 先。Okay. Search and then numbers. 大鬼暗數題。你個篇幅都唔長。Constraints arrays are strictly incremented, strictly decreasing。哎呀，呢句 notice 佢要留嚟。但問題係 left less than right or left less than right minus 1。我哋嚟睇下。For example, this one. 1, 2, 4, 8, 6, 3. Or 0, 1, 2, 3, 4, 5。等陣，忘了你。 我操，有嘢飛！我的媽呀！呢隻飛嘅嘢啦吧？好可怕的東西在飛！咦？同我諗嘅唔一樣。 嗯